Hello. Today we are going to see about graph traversal algorithm. The name of the algorithm is breadth first search. So traversal means we are putting the graph into one sequence of search, or I can just say that we want to visit all the nodes. Say the graph is given one point of graph. If I enter E, I have to visit all the nodes in the graph from E. If I enter from A, I have to go to all the nodes in A. That is what traversal. The meaning of traversal is visiting all the nodes. Okay. So BFS is one way of traversal. So for this example, we have taken this graph for problem solving. So we want to perform a traversal of this graph. You want to visit all the nodes in the graph. We will start from node E. Okay, node E. That's the node we are starting from. So node E is here. We're going to start from node E. Breadth first search uses a data structure called Q. It uses a data structure called Q. Q data structure is used by BFS algorithm, and we will see how the Q is used. And one more output we are having. That's what the output of the um, search the results. Okay, so we'll just put a Q. We have Qs like this, and we have a output like this. This is a Q data structure. This is a output data structure. So we are starting from node E. We are going to traverse the entire thing. It uses Q. BFS uses Q, breadth first search. So first we will start from E. So that should be put up in the output. Whatever you are starting from, that should be put up in the output section, not in the Q section. So if we want to scan from E, the thing is we have to scan from E. So what I can discover if I scan from E, I can discover B. We discover B, then we discover G. These two are directly connected to E. If you see E, E is directly connected to B and E is directly connected to G. So we put B and G as part of the queue. Okay, so this is front of the queue. This is the rear of the queue. Okay, rear. So in here our case, this is the rear of the queue. The queue is having only two elements. This is the front of the queue and this is the rear of the queue. So the next one to scan we have to take from queue. Queue follows a principle called FIFO. First in, first out. That's what queue's principle. First in, first out principle. Queue follows. So that is why we are taking from front of the queue. So I'll take from front of the queue. I'll put it in the output. Front of the queue is B. So I'll take it and put it in the output. Now it contains only G. V is taken out. So rear and both points to the same thing. Rear and front points to the same thing. Now B is in the output. I am scanning from B. I'm scanning from B. So B is connected to F. First of all, F is new. F is not present in output. F is not present in Q. That means I will add F here. Then B is connected to A directly. Whichever is connected directly connection. F and A directly connected to B because adjacent nodes. A is also not there in outputs. A is there not in Q. So I added A, newly discovered. And the B is connected to E. But E is already we have discovered and scanned, even done the scanning also. We have started from E only. So that is no need to add anywhere. Now this is the rear. This is the rear of the queue. That's the front of the queue. Now next time we are gonna scan from front one, that is G. So G is taken out and G is put up in this one. So this is the front. This is the front. That's the rear. So we'll scan from G. So G is connected to A, but A is already discovered. G is connected to E. E is already in the output, so we will not be doing anything. Then next we will be taking and put F in here. We'll put F here. F is taken from front, and so the front is now pointing to this one. So we scan from F. So F is here. F is connected to B, which is already there in the output. F is connected to D, which is not anywhere. So we put D here. Now that will be the rear now. D is added to the Q. F is connected to C. That is also not in the output and not in the Q. That means it is a new one. So it is put up in the rear. This order doesn't matter. So I discovered DC. You can put to CD or DC, doesn't matter. Okay. Now next time I'll just scan again from A, because that is the front of the queue. You got to process always from the front of the queue. Now front is pointing to D. I'll scan from A. A is connected to B, which is already in the output. A is connected to D, which is already in the queue. So we are not doing anything. So then D again moves to the D is again put up in the output, which is the fronts. Now front and rear both are pointing to C. Now D, from D if I scan, D is connected to F. F is already in the output. So D is connected to A. A is already there in the output. So no more to do. So again I'll go with the front. Front is pointed by pointing to C. C is removed now. Now it's not having anything. So front and Q is empty. Now C is here. If I scan from C, C is connected to F. F is already there in the output, and H is new. So I just put a H in the Q. So then this is the front. That's the rear. Both are near. Now H, only one element. So I'll scan from H. Then we'll remove this H from the Q. We'll scan from H. H is connected to only C. C is already there in the output. So no more to go. So Q is empty. So that's the end of the algorithm. No more node I can search from. So Q is empty. That's the algorithm's stopping condition. So this is the output. So you see, this is a breadth first search output. We started from E. We can say it's a level 1. Then you see, E is here. E is here. Then E is connected to BG. You see, E is connected to BG. So we can say that's the next level. So E is here. E is connected to BG. Direct connection. Then the BG is connected to A only. That's the next level. So BG and BG is connected to A and F also, because B is connected to F, G is connected to A. So A and F are next level of nodes. There's a level you can find out. We can just say, so this is the first level. BG, these two are connected to previous level. This is level 1. Okay, this is level 1. These two are in level 2. BG is level 2 and FA is in level 3, and you see, FA is in level F and A are in level 3. Then DC, the DC is in the next level. DC in the next level, I'll just put a different color for that. Then H is in the finally different level. H is in the different level. So that's what. So BG is the next level, which is connected to previous level. FA nodes are connected to BG nodes. Which and which doesn't matter. F is connected to, say for example, F is connected to both B and D, but B is in this level. So F is connected to B, and A is connected to G. A is also connected to B. Both are the previous level nodes. So FA is the next level of nodes connected to BG, then DC, which is connected to FA nodes, and H, which is directly connected to DC. But F will not be directly connected to E. That is what. See, F will not be directly connected to E. Or you can say D. DC is not directly connected to BG nodes. So the level DC is connected to FA, previous level nodes only. DC is not connected directly to BG nodes or E nodes. So this was the breadth first search. You traverse breadthwise. E, then BG, then which is connected to BG, F and A, then which is connected to F and A, D and C, then which is connected to D and C, H. So breadthwise you are covering. So that is why we say it's a breadth first search. Thank you.